Now that we've been looking at how to factor and find zeros, we're going to talk about how to sketch polynomials. So right now, let's label our notes. Just label it sketch polynomials. And the polynomials that we are going to sketch today are going to already be factored. So there's a few things we need to know about how to sketch polynomials. One is we want to make sure that the polynomial is factored. So the polynomial needs to be factored so we can find our zeros. After you factor the polynomial, find your zeros. So once we find or identify our zeros, we also want to identify their multiplicities. Now, multiplicities tell us some behavior around the zero, which we will discuss today. The other piece of sketching polynomials is we want to understand the end behavior, because we need to know what's happening with the ends of the graph. So if we have these three pieces of information, we can do a general sketch of the polynomial. Something else that is a good piece to have is our y-intercept. So we can also use the y-intercept to help us graph. And the y-intercept is the place where the graph crosses the y-axis. And so we are going to be evaluating the polynomial. If it's called f, we're going to substitute in a 0 and find the value that it crosses along the the y-axis. So let's look at first, we want to talk about end behavior. Now, what end behavior is it refers to what the ends of the graph look like. To do this, we need to know both the degree of the polynomial and the leading coefficient. So now, when the degree of the polynomial, if the degree of the polynomial is odd, so any odd number, 1, 3, 5, etc., and the leading coefficient is positive, then what happens to the ends of our graph is they move in opposite directions. For example, a little sketch, just the arrows, mean that on the left-hand side, the graph goes down towards the bottom left, and on the right-hand side, it moves up like this. So we don't really know exactly what happens in the middle. That's going to be determined by the zeros and the multiplicity. But the ends of the graph have to go in opposite directions in this general trend. So what we say is that as x gets bigger, so I'm picking values for x going this direction along the number line, the y values also get bigger. If our degree is odd, but the leading coefficient is negative, then our arrows go in opposite directions, but in the reverse. So our graph, the ends of our graph, will look something like that. So again, we don't know what happens in the middle, but that's what the ends at the moment look like. So an example of what this would look like would be if I gave you a graph like y equals 3x cubed. plus 2x. Now there's some things happening in here, but the general trend of this graph, if I were to sketch this graph, would look something like this. I don't know 100% exactly what's happening here in the middle, but I do know that the ends look like that. So again, you can see that on the left, the arrow is going down, like I made my little guide over here, and on the right, it's moving up. So they are moving in opposite directions from lower to higher. Again, if I change that, and I put a -2, and another odd degree, I mean, even if I just left it like this, a general little picture of the graph would go like this. So it would start high, up in the upper left with an arrow pointing up, and move down to the right. And so that's what we mean when we give these little guides for our arrows, is that on the left-hand side it's going to move up, and on the right-hand side it's going to move down. Now, if the degree of my polynomial is even, and my leading coefficient is positive, both arrows are going up on both sides. So this would be something maybe like a parabola. So let's say y equals 3x squared. Both arrows are going up, and again, the inside, the twists and turns, whatever happens, happens. We'll figure that out. But the arrows on both sides go up. Whereas if the degree is even, and the leading coefficient is negative, they're both pointing down. And again, I could make this a negative 4x to the 6th, plus 2. And what that would look like is both arrows going down, kind of going up like this and shooting back down again. So again, when we're talking about end behavior, it's just to know what happens with the ends of the graph. The zeros and the multiplicities will help us with the inside parts to the graph. So this is our end behavior. It's just a little guide as to what is happening to the ends of the graph. Now let's look at multiplicities. So for zeros, depending on the type of zero you have, your graph will either go through or it will bounce. For example, let's look at multiplicities. So multiplicities of zeros. If you have a polynomial with a factor, for example, of x minus 3, what that means is that I have a 0 where x equals positive 3. And what will happen is over here at positive 3, whatever else is going on, the graph has to go through at that point. So again, I don't know what's happening on either ends, the rest of the twists and turns, but it has to go through that point on the x-axis. This is going to happen every time I have a single factor. Now, when I change that and say I have x minus 2 and I put a square on here, now what this really means is that I actually have two factors. I have two factors of x plus 2. I have two factors of x plus 2, but I only have one 0 at x equals negative 2. So what this means is it means that our 0 is duplicated. And not only is it duplicated, but it does something special. So when I have two factors of the same type, I only have one 0. I mean, a negative 2 is the 0 for this factor, but it's repeated or multiplied on the second factor. So what happens is this exponent up here, when I have an even number, is going to create a bounce. And so over here at -2, I don't know if it bounces up or down, but it's going to hit the axis and bounce back up around that 0. Or, again, it could hit and touch down this direction. That will depend on what is happening on the other sides of my 0. Now, it is possible to also have a multiplicity where I have a binomial raised to a third power. Now, a third power means that I actually have 3 factors of x minus 4. So if I were to expand out my polynomial, I would have 3 of these factors, which means I have 1, 0 at x equals positive 4. So 3 factors, but only 1 unique 0. Right? Just like over here, I have 1 unique 0, but 2 factors from which it came. So now the cubic, or a third degree factor, what that's going to tell me is over here at 4, that running through this is going to look, it's going to go through, but it's going to look a little curvy like a cube. So slightly different than the single one that goes through and looks almost like a straight line. Having 3 is still going to go through, but it's going to look somewhat cubic. So what we're going to do is we're going to look at graphing a few of these polynomials using this behavior.